design because we believe it is empowering and helps reduce the stigma often associated with this work. The spaces you see here are really not typical for the industry, despite their potential to support the programmatic goals of the housing. And related to that, in an effort to do both good and to do better, Matt volunteers with our nonprofit clients throughout the year. This strengthens our connection to and understanding of their work. In fact, one of our most acclaimed projects, Melrose Commons, began as a pro bono effort. Working with a neighborhood nonprofit, we developed a master plan for a 30-block area in the South Bronx, and then for more than 20 years, partnered with local organizations and developers to replace those empty lots and abandoned buildings with over 1,000 new affordable homes. 10 years ago, Melrose Commons became the first project in New York State to achieve the LEED for neighborhood development at stage 2 level. In many ways, this became the cornerstone for our sustainable design that we do today. We are a part of the swift uptake in affordable housing of passive house technologies. In many ways, affordable housing is leading the way in New York City. This growth has been important to help us shift towards a carbon neutral building stock, as we can demonstrate that passive house energy efficiency is indeed achievable in affordable housing. Not only that, we are demonstrating that these technologies create healthier and more comfortable homes. This image explains that shift in technology by Urban Green, which is a great resource. I'm sure this audience is very familiar with the technologies to achieve passive house, so I won't explain them in depth here, but we will give more detail. And on the left, on the left is a summary of those technologies. So this presentation will reveal how one firm has worked over the years to be at the forefront of incorporating passive house technologies. It is a hopeful story of how far we have come in a short period of time and how our goals are within our grasp. We will share some of our challenges, lessons learned, and where we're headed. We found that affordable housing has been at the forefront of passive house adoption, which we attribute to a few factors. The first is developers are more likely to own the property for a longer period of time and will invest a little bit more in the strategies to make them more durable and cost-effective to operate. Also, many of our clients have a mission that is focused on the health and well-being of their residents and communities. And a higher energy performing building and more sustainable building, by today's definition, are indeed healthier. Thirdly, they have agencies that partner with them that have sustainability goals as well, such as HPD here in New York City, which requires Enterprise Green Communities compliance that has an energy cost target that's 15% better than code. This has multiple benefits, but one thing it does is help give owners the vocabulary and knowledge to aim for that next step of energy performance. As you can see in these examples, we use sustainable features as design opportunities. We like to highlight and celebrate them. You can't manage what you don't measure. So to better understand exactly how passive house and energy efficient technologies have shifted the energy performance of our buildings, we are getting closer, and how we're getting closer to passive house levels in our typical project, we put together this timeline of our new construction projects over the past 10 years that we've been fortunate to help create. So the yellow line is the mean energy use of our projects, and the top line is baseline energy code. You can see that the yellow line is taking a deep dive, or in other words, you're seeing the emergence of the affordable passive house. So what we have done here is we've represented the energy performance of our buildings as source EUI, instead of how they're typically represented in sustainability certifications, for example, as % better than this code or that code. We did this because we're searching for an absolute metric in order to understand our building's efficiency across the portfolio. So more on this in a second. The top line is code minimum performance for a multifamily building in New York City. These calculations came from Bright Power, which is an energy consultant. from their database of baseline models. So their database also nicely corresponds corresponds with how ASHRAE has published their percent improvements over time. So in other words, this the baseline is the typical source EUI if we just built a building to code. So you also can see the implications of the stretch code in New York City as well, which in 2022 will get 20% lower, and in 2025, 30% lower from today's levels. The dots in this chart are the source EUI for our specific projects, and the yellow progression again is the mean over time. We will highlight a few projects in this discussion, the ones listed called out here, which represent key milestones in the evaluation of our progress as a firm. You can see how many projects in the first half of this timeline simply followed enterprise green communities, which again was 15% better than code. And for a PTAC building, which most of these were back in the time, that meant 15% EUI improvements. So a chart like this demonstrates our progression in our efforts to adopt passive house technologies such as ERVs and VRFs, and make them more available in our market and therefore more affordable. So we're helping to create the demand for these technologies, which will make them more affordable for everyone. We find this exercise, and we've seen that play out, technologies that have become more affordable over these past 10 years. We find this exercise in establishing source EUI for all projects extremely valuable to be able to understand the technologies where you're implementing across various projects and the performance of those technologies in an absolute term and not a relative term. So accreditation systems are very helpful, but it doesn't really help us compare across projects. I'll go into a little bit about source and site EUI. I'm sure this audience is very familiar, but I wanted to emphasize why we chose source EUI, which is literally the energy use of the building in kilobTUs per year divided by the square feet. Before this calculation is done, though, the amounts of the types of energy consumption, such as electric or gas, are multiplied by a conversion factor established by the EPA. And this factor accounts for all of the losses associated with delivering this energy to the site. So keep in mind that as soon as these conversion factors change, our source energy, the source energy of a building will also change. So as the grid will get cleaner, as it will do in New York soon, our source energies will automatically go down. You can see electric has the highest conversion factor. So all electric buildings actually take a penalty for being all electric for now. This is an Excel tool we created to help us calculate the CO2 emissions according to local law 97 if we have the EUI information. So essentially we start with a site EUI. You can see this is a project that we'll be presenting at the end of the presentation that only uses electric energy. We input that per year, it uses this much, and then we have the conversion factors in the table that convert it to source energy. And then we have the conversion factors for the types of emissions based off of the current law, the current established values from local law 97 and the square foot of the building. And you can see that these are the emissions in greenhouse gas per square foot per year. That is much lower than the targets. These are the targets for our typology. So you see this building will definitely perform well. And this chart also allows us to input energy production. So we definitely separate consumption versus production. So we can really understand how the energy is being used in the consumption of the building separately from just adding solar PV. So it's important to understand when someone gives you an EUI that you know if it's site or source. So you can see that this site EUI is 13.1 0.78 and the source EUI is 38.58. So if you really want to compare, you need to know which type it is. Also important to keep in mind, the passive house metrics are different. PHI uses site energy and FIAS uses source. And the metrics of PHI for the maximum energy that you can use are by square feet, and the metrics for FIAS are per person. So these are the projects we will highlight in this presentation and their source EUIs. We will go into specifics of our current approach to creating these buildings, but we will also show you how the technology has been incorporated into successful projects already, and we're already getting lower EUIs, even if they're not fully passive house yet. Again, source EUI is a great metric and helps us do apples to apples, but it's not perfect. There are nuances to take into account when comparing like this. The density of the building matters. So if you have more studios and more one bedrooms, for example, your EUI will go up because you have more refrigerators and more appliances per square foot. Also, what you count as square feet matters, the energy divided by square feet. So if you have a large space that doesn't get used a lot in that building, your source EUI will definitely go down. And also, again, once we have more renewables on the grid, the source EUI will improve as we electrify our buildings. So our first project example is Creston Avenue. It was completed in 2015 and filed with the DOB in 2012. Again, we give you that reference so you understand what our code baseline was. Conceptually, the sunshades that you see are an echo of the fire escapes in the context. And so this measure of the sunshades on this building drastically improves its aesthetic and celebrates its sustainable function as well. We'll show you this chart for each example building. It gives you the average multifamily building performance and source EUI as it stands currently. The code reference when the building was filed, what EUI it would have been if we had built it to code. And then these are approximate source EUIs for the two passive house certifications. Again, they're estimates because passive house measures things differently than source EUI. And the greenhouse gas metrics for your reference. And for some projects, we may not have the greenhouse gas calculation. Mostly that's because we didn't have the site EUI information, we just had source. And this project achieved LEED Homes Platinum level. At the time, it used high efficiency gas P-tax, which will most likely not be available to be used in the upcoming energy codes. They won't be efficient enough. We use central rooftop exhaust, VRF for the common spaces, and what were also called high efficiency windows at the time. They were aluminum windows with a U value of 0.45, and they were thermally broken. But now we can achieve, for the same cost, we can achieve a UPVC window at about 0.25. So it's dramatically improved for the same cost. We also used these brick standoff clips. So as you know, in the passive house world, thermal bridges are a problem. So without these, you need these shelf angles to support your brick. And you lose about 1/3 of the value of your thermal performance of the facade with once you put these steel angles that go right through your insulation. So these clips were an early version. They're a little clunky and custom designed. So now we have different versions, which you'll see in a minute, but this project started using them back then. And next, Rachel will present St. Augustine in this timeline.
Thanks, Sarah. So St. Augustine Terrace is located on the site of a former church, which was in serious disrepair and unfortunately had to be demolished. The client, the Association of New York Catholic Homes, really wanted to use affordable housing on this site to recreate that community nexus. And so together we conceived of this project as a sort of beacon of light, really anchoring and uplifting the neighborhood. And you can see here that lantern concept embodied in this fully glazed elevator lobby at each floor. Not only does it provide spectacular views of the entire city, but also sheds additional light on the adjacent playground and park and more eyes on the street, which really helps to enliven the neighborhood and build a stronger sense of community. Next slide. Thanks. This project began design as the last project, Creston, was in full construction phase. So we were really able to build upon some of the lessons learned and push those sustainability concepts further. This project was our first to use VRF for heating and cooling throughout the entire building, which was a big step forward in energy savings as compared to Creston's gas-fired PTACs. We had also specified similar windows as Creston. During construction, the GC actually came to us with a proposed substitution on windows for UPVC windows. So that those actually provided far better energy savings over those thermally broken aluminum windows that were at Creston. So we have a 0.28 U value versus a 0.45. And it was at a reduced cost even. We also began using on this project a prefabricated standoff clip for the relieving angles, the ferro-fast clip, which at that point had become more widely available in the New York City market. However, this was the first time using this particular product for both MAP and our GC. And we did have some hard-won but excellent lessons learned on detailing of these. Although I will say it was a big improvement from the clunkier custom-built standoff clip that we used at Creston. We were also able to take similar sustainability features used at Creston, the sunshades, the photovoltaic panels, and make them more. So the sunshades at St. Augustine are functional shading devices, very necessary, as you can see with all of that glazing, but they also frame that iconic lantern concept that we have at the elevator lobbies. And from the inside, they extend the space outward visually. The photovoltaics help offset the house meter, but they're also the capital and the crown of the building. So in this sense, St. Augustine was a big stepping stone for MAP in taking these sustainable features and elevating them and celebrating them as a way to set these buildings apart. Go ahead, Sarah. Is going to present the next one?
Yeah, so we'll present Crotona Senior Housing. This is the first time that MAP used ERVs throughout the entire building. It'll be completed this year. And we use VRF entirely for heating and cooling. ERVs for ventilation. We used a lot of the thermal break details that we've been talking about. So the brick standoff clips. We also used green girts or fiber reinforced polymer. They have some steel reinforcement as well, but it's a thermally broken girt, essentially. And we paid a close attention to thermal bridging details, such as the psi value around the windows, aligning it with the center of the insulation of the thermal R value of the wall. So you can see here, this photo on the right, you can see the green girts a little bit through the cladding. This project is achieving NYSERDA's Tier 3, which is a source, is equivalent to about a source EUI of 64. And you can see the brick columns expressed on the facade are an expression of the bearing walls on the interior, which are perpendicular to the facade. Typically in block and plank buildings and affordable housing, which is our typical structure, the bearing walls are on the exterior. These on this facade are perpendicular, and we've expressed that in the brick with this standoff detail. So these are prefabricated instead of custom. The standoff clips that create the column, and you can see, I've taken this photo from the underside. You can see the thermal break pad between the backup wall and the clip here, and you can see that they have indeed installed insulation inside this clip, which this shop drawing doesn't show, but so that we do have continuous insulation. And next, Rachel will present Linden 2 and 3.
All right. There you go. Thank you. Linden 2 is one of our projects that was a winner of the first round of NYSERDA's Buildings of Excellence program. It's actually the second phase of a 3-building development out in Lindenwood, Brooklyn. You can go to the next slide, actually. Many of you may recall the gas moratoriums that went into effect last summer in parts of Brooklyn and Queens and other parts of New York as well. This actually happened towards the end of our schematic design phase, and it left us in a bit of a pickle. Hedging against the future uncertainty of that natural gas supply chain, the owner of this project decided to go fully electric to avoid those considerations entirely. In order to reduce our energy consumption, of course, we are designing a robust building enclosure with tight air sealing details, double glazed UPVC windows, and energy efficient fixtures, which are all low-hanging fruit at this point and standard practice in our buildings. You can go to the next phase, actually. Similar to previous projects at this point, for heating and cooling, we're using heat pump VRF systems for the entire building. Those have wall-mounted fan units and rooftop condenser units. For this is becoming standard on more of our projects, not all of them, but many of them. However, the challenge for the fully electric building is the domestic hot water. It doesn't matter how efficient the building envelope is or your heating and cooling systems are, domestic hot water follows a different demand curve, which is more behavioral than environmental. So here's a chart showing typical domestic hot water loads over the course of a single day. So the engineers here proposed a multi-pronged system to be a buffer against these peak loads. The main component is maintaining enough hot water storage for those peak loads. You can go to the next slide. We have very large hot water storage tanks at the ground floor to accommodate the entire peak hot water load for the building. Next slide. At the rooftop, we have a pair of heat pump domestic hot water heaters. Those are sized for the entire building, and they're heat pumps. So they are slowly taking heat from the outside air and dumping it into our hot water storage tanks. Next slide. We also have a geothermal loop underneath our parking. It uses this heat exchanger to take heat actually from the groundwater and uses that to preheat water incoming to the storage tanks. Next slide. On sunny days, we have solar thermal panels, which will help to quickly recharge the hot water tanks after that morning peak load when many folks are rushing to shower and get out the door to be off to work. Next slide. And then on very hot days, when our VRF cooling system is working hard, we're using heat recovery units connected to that VRF system, which reduces the load on the heat pump hot water heaters. Next. So this works sort of like a giant water battery, storing energy in the form of hot water, which reduces the building's draw on the electric grid during those peak hot water demands. The next project is Linden 3, which is the third phase of this building here. You can go to the next slide there. This is also planned as a fully electric building. Although that gas moratorium has been lifted, there is still uncertainty in supply lines down the road, and the fully electric system is a way to remove this project from the fossil fuel chain. We do hope to make incremental improvements on the building enclosure on this project from the previous one, most especially in terms of air sealing and our ventilation strategies. You can go to the next slide. This project has similar heating and cooling with the VRF heat pumps and heat recovery that will be connected into our hot water system as well. It will also use, like the previous project, hot water storage and heat pump hot water heaters that will be sized for the entire domestic hot water load. Next slide. However, instead of the multi-pronged hydronic based system that we proposed on the previous project, we're using supplemental electric hot water heaters for this. So on very cold days, when the heat pump hot water heaters might not be working as efficiently or at top capacity, electric hot water heaters will pick up just the difference. This electric load will be partially offset through a photovoltaic array, which generates electricity during the day, happily coinciding with two of our peak loads, the morning rush and the dinner rush. And then overnight, the domestic hot water pumps, domestic heat pump hot water heaters will continue to recharge those storage tanks in anticipation of that morning rush. So in this way, we are still working towards being a better grid citizen to shave our peak demand draw on the electric grid. Next slide. So because these two projects are almost equally sized, they're on the same site and they have almost identical resident populations, we're hoping that they can stand as important case studies for comparing different strategies to solve this hot water problem in the most economical and cost-efficient way. And Sarah's going to take it up for our next project, DeKalb Commons.
Or Rheingold.
Oh, Rheingold, sorry.
Yeah. So this project is senior housing, half studios, half one bedrooms. It's designed to FIAS standards, but it won't quite meet FIAS because mostly because of the density issue that we have that I mentioned earlier. So we have a lot of refrigerators, a lot of appliances per square foot. So if we wanted to meet the FIAS targets, we would have had to decrease our proportion of studio apartments or double the size of the PV array or reduce our glazing, which is already at only 27% window to wall area ratio. So we're, even though we're not meeting the targets, it's a very efficient building. You can see this is the site. And this is our typical floor plan. We're using the technologies that we've discussed. So the ERVs, energy recovery ventilation, is a central system. And the shafts for those are in this often underutilized space between Appendix P bathrooms behind the tubs. And we also are using VRFs, and the risers for the VRF, the refrigerant, are on the exterior wall, which is very close to the evaporator. So it reduces the distance of horizontal runs of refrigerant, which increases the efficiency, reduces the embodied energy of the whole project, reduces potential for leaks. So that is another reason why we've also, most of our units are stacked vertically, and we don't change the layout to as few times as we can. To just mention the design, the west side of the site is a narrow lot, and so we couldn't fit in a double-loaded corridor. But we took the opportunity to do what we often do in our senior buildings, and provide a generous elevator lobby for people to either spread out or meet socially, or for private contemplation. And we have a glazed portion for them to look out at that lobby here. These are our metrics for this project. This was one of our Buildings of Excellence Award winners as well. It's targeting FIAS. So we took the opportunity with this project to really examine the cost difference between, we had 4 GCs price out a passive house alternate. And our baseline was a project that had the same system, so the same VRFs and ERV systems. But again, if you increase the envelope performance of your building with a passive house, you can actually decrease the size of those VRF and ERV systems. So mostly the condenser can get smaller. So we found that this alternate between a building with the same systems that had that energy target for that building was NYSERDA's Tier 2 target, which is 25% better than code. And so using the same systems, we had the GCs priced at comparison. And these are all the items that had to change just slightly to get from that NYSERDA target to the passive house target. And we found that it was less than 1% of a cost difference. And then you can see the annual savings and operational savings is $52,000. And you can see the difference in source EUIs for the NYSERDA version versus the Passive House version, this Passive House versus NYSERDA version, NYSERDA Tier 2. So these are the metrics, the R values for this project. Again, it's typical Passive House values for this typology and this geometric configuration. And the systems as well, pretty standard. The cladding design, we also pay close attention to make it very efficient, have a very low waste factor in our design, also make it not cumbersome to create shop drawings for, and not cumbersome on site, but also provide a nice aesthetic that harkens back to the brick context. So these panels are full size, they don't have to be cut, and we don't need shop drawings to create this pattern. It's just a pattern that you follow on site. These are a close-up of those thermally broken girts that we mentioned before. We're using them again for this project, and we've sized the spacing of them to be equal to the size of a typical stone wool insulation board. And so the installation works very efficiently. The two go up together at the same time. So it's attached on the left-hand side with the girt and then pinned, and then the next girt comes in behind it. So and you can see the effect in the different, by using the girt here, you can see the difference in the thermal flows. These are some details from that project. We're aligning the windows again with the center of the wall, which is a pretty straightforward way to improve the thermal performance of your enclosure. If you're unsure and you don't want to do thermal modeling, the best bet is to put it at the back of your insulation, and that should keep it in line with the thermal flow through the wall and prevent condensation as well. Here we're using, we're wrapping our parapet with insulation, but we're using an aerated autoclaved concrete block here, which in other places is very widely used, and it's just kind of making its way over here. We're also looking at using foam glass gravel, which is a very exciting product. It replaces two different materials under the sub slab. So it's, instead of insulation or a high global warming potential foam insulation and the gravel layer, we can use this foam glass, which is, excuse me, recycled glass that has been expanded with CO2 actually, and has an R value. It's used a lot in civil engineering, but it serves two functions, and so far we've only noticed a difference in cost. But for this building is only a $20,000 change order possibly, but we think that's partially because of the novelty of it. And two manufacturers have opened up in this area to provide this product recently. So, one's in Philadelphia. The next project is DeKalb Commons. So actually you can see Rheingold has about the same source EUI as DeKalb, but DeKalb is able to certify to Passive House because it's not as dense. So it has less, it has different metrics. Again, the cladding design reduces waste. These are full-size panels. Our entrances don't have canopies. They have pergolas to emphasize the fact that this is Passive House and we want as few penetrations through the thermal layer as possible. These are the metrics. Excuse me. There are two buildings across the street from each other. We pay close attention to mitigating embodied carbon in this project, but you can see on the left-hand side our values for our windows. And so in many instances, we're finding that we don't need to provide triple glazed windows. It really depends on the geometry of your building. It depends on the loads. You do not always need triple glazed windows. And we think that's important because people get nervous about the weight and the cost of triple glaze. So with this cladding design is similar to Rheingold's in the fact that we're using stone wool insulation. It's a rain screen, but here we've actually eliminated the girts. We're using a screw-through solution, which has a really dense insulation, and this has allowed us to reduce $5 per square foot of material cost for the same performance. And we just to show you, we've started modeling some of our projects in EC3 to kind of look at the embodied carbon of our structures. And there are a lot of ways to reduce already embodied carbon pretty simply in this area, but actually California is a little bit ahead of New York in that regard. So they have things like Positive, which is a recycled glass, supplementary cementitious material. They have also Carbon Cure. So we're looking at getting some of that over here too. And the last two projects are down here at the bottom. They will both go for PHI certification. This one's using a prefabricated facade panel. And then this one is called the Rise. It's an early design and it focuses on urban farming, and it will go for PHI certification. It's a supportive housing building using trauma-informed design. So it was part of the Vital Brooklyn RFP, and it's very much focused on health. And so that's part of the reasoning behind the urban farming, and also focusing on self-reliance. So this focus on health, again, is a big issue right now, and we're thinking about how our passive house technologies influence the conversation around mitigating contaminants, not sharing air, having proper ventilation. So we just wanted to contribute to the conversation in that way. Our thoughts are that, which has been repeated elsewhere, is ventilation is extremely critical. ERVs in our typology are the best way to actually ensure that that ventilation is delivered. If you have exhaust-only ventilation, you're pulling your fresh air from the corridor, you're pulling it from your neighbor's apartment. You're not really getting fresh air. Trickle vents, we find, don't often work that well. So ERVs are really a good solution. There is a minimal amount of air transfer at the unit itself. It depends on the type of ERV, but we believe that we're thinking that actually providing ventilation is probably a better solution than having that small transfer, which might be 1 or 2%. And again, the engineers and thinking so far is that dilution and dispersion is the best strategy. So also ERVs help control humidity, which supports human health and our immune system functioning properly. So with that, we just wanted to leave you with some resources, and these are some of our favorites here in New York City, and we have time for questions.
Yeah, Sarah, we had a few that came in through the chats, and I'm going to kind of tackle them in the order that they came in. There was a question about whether or not MAP has any prefab modular in part or whole. And actually we have a handful of prefab projects, none unfortunately in this presentation, some in design and some finished in construction and some nearly finished in construction. We're finding that the current market for delivery of the modular is really the choke point, not the interest in modular at the moment. There are fewer companies that do modular, so that makes it, I think, the most tricky. Sarah, would you agree with that for us at the moment?
Yes.
Is more exactly. The delivery, not the drive for it.
Right. I think there's also a lot of interest in prefab panels. So I think the more that you can prefab and save on material costs, provide better working environments, provide more controlled environments for quality control, things like the air barrier. That can be done pretty well with prefab panels, exterior walls, and things like that too. So maybe that's a half measure we can do sooner rather than modular boxes.
Agreed. We have another question about heated or chilled slabs as a way to get away from refrigerant-based cooling. When I talked a lot about the heat pumps, we actually didn't address that big elephant in the room, which is the refrigeration, the refrigerant that's used. And right now it's got a much higher greenhouse gas coefficient than even carbon. There are incremental improvements in the works, but we just have not yet seen those in our market. So that's an important factor. We don't have any chilled slabs in our projects, actually. I can think of.
No, we don't really use radiant heating or chilled beams, or chilled beams I think have to work when you have an enclosed building. You can't really open windows. But
for our typology, I don't think we have had any so far.
I would be very interested to know if a hydronic distribution works with heat pumps to heat a building. If we can do hot water with heat pumps, then can we do hydronic heating with heat pumps? And I've seen some indication that people are looking at that, but it's not available
right now. Still working out the kinks.
And the types of refrigerants are changing, like you said. Like they're looking at lower global warming potential ones, but I think it's the fact that they're slightly flammable. So it's getting that, solving that with a low global warming potential is hard.
Right. There was also a question about the cost per square foot. I don't have cost per square foot for all of these projects, but I know for at least the ones I presented, they range from around $250 a square foot to $350 a square foot. Some of our senior buildings, because of the way our funding works with the affordable programs, they have PLA or our union labor, and those are looking at more around $450 a square foot. It also depends on, for most of us, the structure and the foundations can be a big cost differential for these particular types of projects. And then there was another question about, I'm trying to see if these are, there's a lot of really good questions. So I'm gonna take them as they sort of came in. The question about how we think COVID will change the affordable housing market, which is a really big question that would take probably another 10 presentations to go through. But certainly, I think, Sarah, you touched on this a bit when you talked about ventilation and compartmentalization, I think is important for that as well in terms of housing, for affordable housing. Become very clear that you can't shelter in place if you have no shelter. And so affordable housing is very important for tackling these problems that have been made more clear during this pandemic.
Yes. I wonder also if personal outdoor space, or the ability to open your windows a little bit more, or have Juliet balconies, or even your own balcony might become part of our design if we do have to shelter in place. And also, as you're saying, ventilation, the fact that ERVs are much better at actually providing air changes. We have things that we design to, but we don't actually measure or test how many air changes are happening in our apartments. So maybe that will become part of our testing. And of course, while we mention the risks of ERVs, I think just actually making sure that we have good ventilation with them is really important, and it fits in with our energy goals too.
Yeah. Yes. Agreed. One additional question was regarding the screw-based cladding attachment that you talked about. The question is for the cladding backup system using screws rather than deeper girts, does the cladding shift drop due to shear failure or deflection of screw? And that actually had to do, I believe, with your choice in the particular cladding. There's a weight limit that that system will work on, correct?
Right, exactly. The insulation has to be dense. So for example, if you use Rockwool, it's density comfort board 110. And they have weight limits. So I think the highest weight limit you can go to with that system is 10 pounds per square foot, but we're using much lower than that. And it's been tested.
Yeah, there are test reports for all of that on one of the links that I believe that Passive House posted in the chat here. Let's see here. Large buildings are small.
Oh, and I also mentioned just another thing about materials. You know, and the spread of viruses, it's important that we be very careful about using products that claim to be antimicrobial because they're actually, and Kaiser Permanente has published this, you know, not that long ago, that actually we don't know the impacts on human and environmental health of all those antimicrobial materials, some of which are nanotechnologies, which we don't have a lot of information on its effects. So it might be, it's probably smarter just to make your surfaces cleanable. Also copper and copper alloys are antimicrobial. So if you want to use that in select places too.
Yeah, high traffic areas, doorknobs.
Yeah.
And
and also reducing the amount of materials in our buildings that cause asthma, which, you know, if you have that as a precondition, makes your battle with COVID a lot worse. So there are a lot of products that we use. We're looking at using more healthy materials as much as we can.
Yeah, a growing emphasis on that as well. There's a question, let's see here, some material-based questions. Just seeing music, AC, nature. Okay. Here we go. Sarah, is there a product that you can't get that you'd most like to see in our market, at least?
Can I say two? Okay.
Yeah.
So one of them is definitely getting Carbon Cure and Positive into our concrete choices. And the other is retrofit VRF heat pump PTAC type units.
Yes.
So I know that they're coming. But I'd like to kind of just hopefully that process can be sped up, and because it's great. You know, you just put in this box by your window. It's a heat pump, so you know, same technology as your air conditioner, but it provides heat and cooling, and you don't have refrigerant runs between units. So it's just at your apartment. This wonderful retrofit solution.
Yeah. Yeah. And our presentation dealt solely with new construction projects, but
yeah,
you know, retrofit is imperative both in reducing our overall energy usage, but in creating healthier homes for more people. A lot of retrofit is required. And again, the refrigeration has come up. There was a recommendation to look at Robert Bean's work regarding exergy and refrigeration-based heating and cooling systems.
Great, thank you.
Yeah, and then with regards to concrete, we have a question about organic concrete, like hempcrete, and I'm not familiar with that yet. I don't believe we've had that in any of our projects. Now we are able to specify. You're working in some specifications, correct, to specify products in concrete for lower carbon?
Right. But mostly what's available now is mostly just slag and fly ash. But the book, New Carbon Architecture, outlines the new technologies in concrete really well. I think there's some options with clay. I feel like, you know, and the fact that we have these bacteria grown bricks now available, it seems like we've been very much focused on the certain types of solutions in the past, you know, generations or so. And now all these ideas are coming to the forefront of other biological or biomimicry solutions that we haven't really touched yet. So
Yeah.
Exciting.
All right. We have some excellent suggestions through the chat for additional resources coming in.
So I would say we take one more question,
yeah,
and we will send out an email, or Map will send out an email, and you can always you know, go more in detail with you guys and with anyone who has questions then.
Great. Andres, would you like to pose the last question? I don't see.
No, you can take one if you like. Choose one last questions.
One last question, sure. So let's see here. This one is actually maybe a bit challenging. The question is, will it be easier to make housing more affordable in large buildings or small buildings? And is there a sweet spot?
Can you repeat that again?
Sure. Well, is it easier to make housing more affordable in large buildings or small buildings? And is there a sweet spot? And I think there are a lot of factors at play there too. There is, of course, the way that buildings are financed, which sort of, you know, projects under a certain size become less feasible. What we've seen a challenge for making buildings more sustainable, of course, is the density of equipment. You showed an example between Rheingold and DeKalb that had similar EUI,
right.
but we're unable to meet certification standards differently. So,
yeah, I mean, I think if you build a really, really tall building, so above 12 stories or 15 stories or so, then you have to have much stronger foundations and structure, and that gets very expensive. So it's sort of, you know, like that lower range below that is probably the most cost effective, which aligns with our R6 and R5 zoning.
Right. I'm seeing some agreement here in the chat as well. Monty from RDH seeing mid-rise as sort of a sweet spot for this, and larger projects better for land cost. But it's those smaller projects that sometimes can be trickier to make work in the affordable housing world.
Yeah.
Okay. So I would like to thank Sarah and Rachel for the great presentation. I would like to thank everyone for joining us. Please join the Passwords conference starting next week on Wednesday at 1 p.m. and check back with us. We organize quite many more interesting presentations on our platform as well. So I would like to thank everyone and thank you guys for the presentation.
Thank you.
Thank you.